Hi, Earth Science guys. I'm gonna start with part one of your notes for Monday. On part one, you guys will notice that there's a picture of a globe, and then there's three parts that you need to label. The first part is gonna be the 0 degrees. That's the center line that's running down the globe, and that's called your equator. Okay, so go ahead and label 0 degrees, equator. To the north, we have another line at about 23.4 degrees. Sometimes they say 23.5 degrees. And this is called the Tropic of Cancer. So on 23.4, up in the north, you have the Tropic of Cancer. Below that, in the south, you have something called the Tropic of Capricorn. So go ahead and label the 23.4 in the south, Tropic of Capricorn. Okay, so that's all we're gonna really talk about for part one. I do want you guys to associate yourself with what the globe is, why it's sitting the way it is. So here you have your axes. If you notice, there's this black framework on it, and the globe is naturally tilted. That's because our Earth is tilted 23.5 degrees at all times. So here you have your North Pole axes, and then coming out of the bottom is your South Pole axes, okay? Okay, so part two, we're going to talk about the difference between a revolution and rotation. Earth rotates every single day. This is what causes the sun to rise in the morning and to set at night. So this is the rotation. Earth also revolves. So if you guys notice here, I have a light. Imagine that the light is coming out on all sides of it. This is going to symbolize our sun. And so the Earth will revolve around the sun. Okay, so those are your two main differences: rotation, days and nights; revolution, seasons. Okay, so to continue part two, on your guys' notes, you have on the left side a portion where it looks like the Earth is moving around the sun. I want you to label that revolution. So underneath on the left, label the part where the Earth is rotating around the sun as the revolution. On the right side, you'll see the Earth is rotating like this. Label that rotation. Underneath both of those, try to remember from earlier which one, either the rotation or the revolution, causes day and night, and which one causes seasons. Add that to your notes as well. Okay, we're going to move on to part three. Part three is talking about why we have seasons, and you guys on your note sheet will have a diagram with the sun in the center and the Earth rotating at 4 different points: point A, B, C, and D. We're going to start with point A. Okay, so if you notice, the sun's in the center. Point A, your axis is pointing towards the sun. So if I were to extend this portion out and the southern point out, the northern hemisphere is pointing towards the sun. That means that the northern hemisphere is experiencing summer at this point. And the reason for that is because your direct sunlight is focused on your Tropic of Cancer. So on your notes for letter A, make sure you write summer, and you show that the direct sunlight is pointing at the Tropic of Cancer. A really good way to remember this is in the summer, the sun can cause cancer. So Tropic of Cancer is your direct sunlight path. Okay, so that is point A. Point B, now your Earth has moved to the side of your sun. The axis is not pointing towards the sun or away from the sun. So at point B, you go summer to fall. So point B, you should have fall. Now, if I had a light that wasn't only pointing in one direction, you would see direct sunlight on the equator. So on your notes, I want you to write that for letter B, direct sunlight is directly on your equator. Okay? The next point that we are going to go to is, imagine the Earth going around the sun. And I'm going to actually flip my sun around. Notice now we are at point C on your notes. and that the axis is pointing away from the sun. So if I extend this portion out, the northern hemisphere is pointing away. Now, take a moment and think about, my axis has always been pointing in this direction, okay? Now, the northern hemisphere is experiencing winter. Direct sunlight is on the Tropic of Capricorn in the southern hemisphere. We are experiencing indirect sunlight. That is why we are experiencing winter and they're experiencing summer. So in the southern hemisphere, it's summer. Northern hemisphere, it is winter. So at point C, make sure you write that this season is winter and that direct sunlight is on the Tropic of Capricorn. Okay, our final point is point D. So now this one, you're not gonna be able to see the sun from the angle. That's okay. Again, this point is just like point B, but except for we went from summer on this side. Point A was summer, point B was fall, point C was winter, point D is now spring. Again, your axis is not pointing towards the sun or away from the sun, and direct sunlight is going to be on the equator. So make sure you label point D spring, and then you make sure that you say direct sunlight is on the equator. Okay, so just to recap part 3, I've switched out the light to have a standing light that shows light in all directions so you guys can see the rotation and revolution a little bit better around the sun. So right now, my axis is towards the sun. So on part 3 of your notes, this is showing you summer in the northern hemisphere. Right now, the United States is also facing the sun. So that means we are experiencing daylight. When this rotates, it becomes nighttime for us. Okay? So now, as this goes around the sun, remember the axis is always going to be pointing in one direction. Now we are experiencing fall. So this is point B on your notes for part 3. The United States now is towards the sun. We are experiencing daylight. As the earth rotates, it becomes nighttime. Over the course of a year, our earth continues to move around the sun. The axis is now pointing away from the sun, meaning we are experiencing winter. Again, as the earth rotates, we experience night and day. Okay, so this is part C, winter. Then as it moves again, and remember this is a continuous revolution, that's why we have a year. It takes 1 year to revolve around the sun. We are now experiencing spring. The axis is not towards the sun or away from the sun. And as this rotates, we experience night and day. So revolution is how it's revolving, okay? And that causes our years and seasons. The rotation causes night and day. All right, so part 4. This is a huge misconception a lot of you guys have. If I were to ask you why does the earth have seasons, many of you would say because sometimes in the summer, the earth is closer to the sun. And then in the winter, it's farther away from the sun. This is not the case. It's actually opposite of what you think. In the summer, the earth is actually farther away from the sun. The reason we have seasons is because the axis is pointing towards the sun. In the winter, the earth is closer to the sun, okay? The direct sunlight is just in the southern hemisphere, and indirect sunlight is in the northern hemisphere where we live. So on your guys' diagram, make sure you label when the earth is furthest away from the sun, label it summer. When the earth is closer to the sun, label it winter. And that's it.